Enterprise JavaBeans, or EJB, is a server-side component architecture for building robust, scalable, and transactional enterprise applications in Java. Introduced in the late 90s, EJB aimed to simplify the development of complex enterprise systems by providing a standardized framework for handling common concerns like persistence, security, and transactions. In the early versions of EJB, versions 1.x and 2.x, home interfaces played a crucial role. Think of Enterprise JavaBeans as a set of building blocks for creating really powerful and complex applications. These building blocks are like specialized components that can be assembled and reused. Early versions of EJB relied on something called home interfaces, which acted as blueprints for creating these components. They were essential for controlling the lifecycle of these components. The primary function of a home interface was to act as a factory for EJB components. Just like a factory produces goods, a home interface was responsible for creating instances of EJB components. Developers would interact with the home interface to obtain references to EJB objects, which they could then use to invoke business methods and perform operations. Think of a car factory. The factory has blueprints and assembly lines for creating various car models. Similarly, a home interface in EJB provided the blueprints for creating EJB components. It defined methods for creating new instances of a specific EJB type. When a client application needed to utilize an EJB component, it would first interact with the home interface to obtain a reference to a new or existing EJB instance. This was akin to ordering a car from the factory. The factory would then manufacture the car based on the blueprint and deliver it to the customer. This factory-like functionality of home interfaces provided a clean separation between clients and the underlying EJB component creation mechanism, simplifying the development process and promoting modularity. Home interfaces also played a crucial role in managing the lifecycle of EJB components. The EJB container, which is the runtime environment for EJBs, relied on the home interface to control the creation, initialization, passivation, activation, and removal of EJB instances. The lifecycle of an EJB component, like any software object, involves its creation, usage, and eventual destruction. Home interfaces were instrumental in orchestrating this lifecycle in conjunction with the EJB container. Think of it as a control panel for managing the EJB components. When a new EJB instance was required, the container would invoke the appropriate method on the home interface to create it. Similarly, when an EJB instance was no longer needed, the container would use the home interface to remove it, freeing up resources. Home interfaces facilitated the management of EJB instances throughout their lifespan, ensuring that the container could efficiently allocate and deallocate resources, optimize performance, and maintain the integrity of the EJB ecosystem. One of the key benefits of using home interfaces was the abstraction and encapsulation they provided. By interacting with the home interface, clients were shielded from the complexities of EJB component creation and lifecycle management. They didn't need to know the intricate details of how EJB instances were instantiated or how their lifecycle was controlled. Think of a TV remote control. You use the remote to interact with the TV without needing to understand the complex electronics inside. Similarly, home interfaces acted as a simplified interface for interacting with EJB components. Clients could simply request an EJB instance from the home interface without worrying about the underlying mechanisms. This abstraction made it easier for developers to work with EJBs, as they could focus on the business logic rather than the technical intricacies of component management. This encapsulation also promoted code reusability and maintainability. Changes to the EJB component implementation could be made without impacting clients, as long as the home interface remained unchanged. To illustrate the concepts of home interfaces, let's consider a real-world example: a shopping cart in an e-commerce application. In this scenario, let's imagine a shopping cart EJB component that manages the items added by a user during their shopping session. The shopping cart home interface would act as the factory for creating and managing instances of the shopping cart EJB. When a user starts a new shopping session, the e-commerce application would interact with the shopping cart home interface to create a new shopping cart EJB instance, representing the user's empty cart. As the user adds items to their cart, The application would invoke methods on the shopping cart EJB instance to add or remove items, update quantities, and calculate the total price. The shopping cart home interface would provide methods like create, find by customer id, and remove to manage the lifecycle of shopping cart EJB instances. The create method would be used to generate a new shopping cart instance for a new user session. The find by customer id method would allow the application to retrieve an existing shopping cart instance based on the user's ID. Finally, the remove method would be used to delete a shopping cart instance when the user ends their session. By utilizing the shopping cart home interface, the e-commerce application can manage user shopping carts effectively without directly dealing with the complexities of EJB instance creation and lifecycle management. Home interfaces defined a set of methods for managing EJB instances. These methods typically included create, find by primary key, and remove. The create method was used to create new EJB instances. It often had variations to accommodate different initialization parameters for the EJB. The find by primary key method was used to locate an existing EJB instance based on its primary key. The primary key is a unique identifier for an EJB instance, ensuring that each instance can be retrieved unambiguously. Think of it like a product ID in a catalog. It helps you find the exact product you're looking for. The remove method, as its name suggests, was used to delete an EJB instance. This method would typically take the primary key of the EJB instance to be removed. Once invoked, the EJB container would handle the removal of the instance, ensuring proper resource cleanup. These methods provided the essential tools for managing EJB instances throughout their lifecycle, from creation to retrieval and removal. In addition to the home interface, EJBs also had remote and local interfaces. The remote interface defined the business methods that clients could invoke on the EJB component. It was used for communication between clients and EJBs that resided in different Java virtual machines, JVMs, often on different physical servers. The local interface, on the other hand, was used for communication between clients and EJBs within the same JVM. It provided a more efficient way for clients to interact with EJBs locally, without the overhead of remote communication protocols. Think of it as a direct line of communication compared to a long-distance call. The home interface was responsible for providing access to both the remote and local interfaces. When a client requested an EJB instance from the home interface, it would receive a reference to either the remote or local interface, depending on whether the client and the EJB resided in the same JVM. This separation of interfaces allowed for flexible communication patterns, supporting both remote and local interactions between clients and EJB components. The EJB container, the runtime environment for EJBs, provided several essential services that relied on the home interface. These services included transaction management, security, and concurrency control. The home interface acted as a conduit between the container and the EJB component, facilitating the provisioning of these services. Transaction management ensures that operations on EJB components are executed reliably and consistently, even in cases of failures. The container used the home interface to demarcate transaction boundaries, ensuring that operations were either completed successfully or rolled back entirely, maintaining data integrity. Security services provided by the container included authentication, authorization, and access control. The home interface played a role in enforcing security policies by ensuring that only authorized clients could create or access EJB instances. Concurrency control managed concurrent access to EJB instances from multiple clients, preventing data corruption or inconsistencies. The container used the home interface to coordinate access to EJB instances, ensuring that simultaneous operations from multiple clients did not interfere with each other. As the EJB specification evolved, the role of home interfaces gradually diminished. In EJB 3.0 and later versions, the concept of home interfaces was removed and annotations were introduced to simplify EJB development. These annotations allowed developers to specify the EJB type, interface details, and lifecycle methods directly within the EJB component code, eliminating the need for separate home interface definitions. This shift towards annotations streamlined the development process, making it easier to create and manage EJB components without the overhead of maintaining separate interface definitions. EJBs became less cumbersome to work with, encouraging wider adoption and simplifying the development of enterprise applications. Although home interfaces are no longer a part of modern EJB development, understanding their role in earlier versions provides valuable insight into the evolution of the EJB specification and the design principles behind enterprise component architectures. Home interfaces were a fundamental concept in early versions of Enterprise JavaBeans. They acted as factories for creating EJB components, providing methods for managing their lifecycle, abstracting away the complexities of component creation and management, and facilitating the provisioning of container services like transaction management, security, and concurrency control. Through the use of a real-world example, such as a shopping cart in an e-commerce application, we illustrated how home interfaces simplified the interaction between clients and EJB components, enabling developers to focus on business logic rather than the intricacies of EJB management. While home interfaces have been superseded by annotations in later EJB specifications, their legacy provides valuable insights into the evolution of enterprise component architectures and the principles of abstraction, encapsulation, and lifecycle management that remain relevant in modern software development.